Okay, so welcome back to momentum, right? So chapter or unit 4, linear momentum here in AP Physics C. So some of this may be a review from last year, as much of AP Physics C is, but we're going to bring in that calculus piece. So an easy way to think about momentum, or a simple definition, is inertia in motion. Okay. Now the actual definition, right, is the idea that linear momentum of an object is defined as the product of its mass and its velocity. Well, inertia is mass, motion is velocity, right? And that definition leads us right to the equation, P equals mv, right? So momentum is equal to mass times velocity. So you have the vector logo, or the vector symbol. So momentum is a vector, which, remember, we need to account for the direction. Now, recall, so a lot of this is a simple review from last year. So we need to give the object a force to get it to change its momentum, because we want to change pieces of it, right? So we're either going to increase it, we're going to decrease it, or we're going to change its direction, right? And so with the force being brought into this, we can now rewrite or translate Newton's second law into a more modern language, which brings in the calculus piece, right? So the rate of change of momentum of an object is equal to the net force applied to it. So the way you can think about it, apologize for that, is momentum, right, or force, is the rate at which the rate of change of momentum is the force applied to it, right? So we're going to say F equals dP dt, or sorry, delta P delta T, right? Now, this is specifically for average force. Now, how can I find like the instantaneous? Well, I use my concept of rate in calculus. And remember, rate in calculus is a derivative, right? It's the slope. So what we're saying is that force is the derivative of momentum, okay? I can rewrite this equation. Actually, we'll talk about that at another point here in another video. But this is the instantaneous force. Now, a lot of times students ask, like, well, how do I know to use the derivative or just the average piece? Typically, if something is, like, let's say momentum is given to you as an expression with respect to time, you're probably going to find an instantaneous force. Okay, if we're doing something with numbers or so forth, you're probably going to be looking for average. Okay, but remember also, change of momentum is m delta v, right? Even at this level, we're not going to change, talk about mass varying. We're going to talk about velocity varying or changing. So here's an example. So for a top player, a tennis ball may leave the racket with a speed of 55 meters per second, which is about 120 miles per hour. If the ball has a mass of 0.060 kilograms and is in contact with the racket for about 4 milliseconds, estimate the average force on the ball. Now, the second question is, would this be large enough to lift a 70 kilogram person? So yeah, when you serve, the ball is traveling upwards, but you have to remember the racket will exert a force linearly, right? And then it's going to cause the ball to change its position that way. Okay. So yeah, the velocity will change, right? Because if I think about it, in the x direction initially, it's not moving, right? It's only moving vertically. But then here, afterwards, right, in this scenario, we're going to be moving 55 meters per second. And so I can say that the force, right, the average force is my delta P over delta T, which is going to be m delta V over delta T. And remember, delta V is V minus V0. But V0, my initial velocity kind of horizontally, is 0. So it's going to be mv over delta t, which is going to be a very easy calculation because it's going to be 0.060 kilograms. Now, you do have to be careful because sometimes they give that to you in grams, which means you would need to convert. We're going to multiply that by 55 meters per second, and we're doing it in a time of 4 milliseconds. But we need to convert that 4 milliseconds to seconds, which is 4 times 10 to the negative 3. So what is the average force that we exert on the tennis ball? It's going to be 825 newtons. So we apply 825 Newton force to the tennis ball. Does that, or would that force allow us to lift the 70 kilogram person? So remember, when we talk about lifting, we have to lift at minimum the weight of the person. So it's going to be 70 times 9.81 or 9.8, which tells us that they have a weight of approximately 690 newtons. And so that tells me that the force given to the tennis ball is greater than the weight of the person, which means I can lift them up. Okay, so the same force that you give to a tennis ball would allow you to lift a 70 kilogram person, which is roughly 150 pounds. Okay, so there's just kind of our intro about momentum. Next, we're going to talk about impulse and